In this video, I'm going to show you how to hook up your switch. Your switch should be connected to your robot chassis as shown, and you're going to use these terminals on the switch in order to connect the wires so that you can route them to your breadboard. There's at least two ways for you to hook up this switch. You can hook up the switch to be normally closed or normally open. If you look at the inscription on the switch, you can see that these two terminals, one is labeled normally closed, one is labeled normally open, whereas this bottom terminal down here is labeled common or ground. You'll always use this common terminal, and then depending on how you want to have it hooked up, you'll either connect your other wire to the normally open or the normally closed terminal. Normally closed is when the switch is always closed, and when it's activated, it opens it up and prohibits the flow of electrons. So normally closed would be if you had it connected to an LED, that LED would be lit up anytime you're not pressing the switch, but when you press the switch, it opens it up, and now the LED doesn't light. Normally open is probably what you think of more often when you think about a switch. A normally open switch is the circuit is open, and say this is connected to an LED, and if you were to press the switch, you would close the circuit, and then the electrons would be able to flow and light the LED. We will hook our switches up to be normally open. In your kit, you should have gotten 2 disconnect terminals. You're going to need to use 2 disconnect terminals along with 2 wires from your jumper wire kit. I recommend choosing 2 wires that are different colors so that you'll be able to follow along with the routing of those wires as you route them through the hole in the robot chassis. Now you need to prepare your wires to be connected to your switch. I'll use my pliers along with the 2 wires, the 2 disconnect terminals. Now your terminals may or may not have this plastic coating on them. This is good because it keeps it insulated in the event that any of the wires would touch. However, it does make it difficult for you to close these terminals. So what you do is you will slide your wire through, and now you can see it going through the hole and coming out. I can push it all the way out, but you don't want to have it that far. You just want to have it to where it butts up against that raise in the disconnect terminal. Now, once you have it in there, you'll need to clamp it to close it on that wire. Now, this is what I was talking about with that plastic, how it gets really difficult. I can't physically close it myself. So what I like to do is I like to pull that insulation off, and it makes it easier for me to just close it onto the metal of the wire. So I can just use my pliers to pry that plastic off. I might need to use my precision cutters to cut it, but it makes it easier when you remove that plastic. Once you get the plastic insulation off of the disconnect terminals, I think you'll see that it'll be easier for you to clamp the wire onto the terminals. An alternate technique, instead of removing the plastic, would be to maybe come during help desk hours. You can leave the plastic on there and hold the wire in and use the vise near the milling machine station and clamp the wire into the disconnect terminal. However, if you're using your pliers, getting that plastic off will be helpful. So you can slide your wire through, and then you can use your clamp from your pliers. You might want to put them down here, down as far as you can go without cutting it to give you a little bit more leverage, and then squeeze tight, and now you have your wire prepared inside your disconnect terminal. Repeat that process for your second wire. Give it a tug. If it comes out, you might need to reclamp it. Be careful to clamp it too much because this aluminum that these disconnect terminals are made out of can easily break. Once you have the disconnect terminals and the wires prepared, you need to put them on the switch. So in order to put the wire onto the terminal of the switch, you'll need to use your pliers, clamp them onto the base of the terminal, and then you're going to have to maneuver it onto the terminal of the switch. Now this can get very difficult. You need to line it up perfectly in order for it to slide the way you need it to slide on, and you're going to have to use a lot of force to slide it appropriately. In order to hook the switch up as a normally open switch, you'll need to slide the wire onto the second terminal on the switch. Now this again will take a lot of wiggling and trying to get it on there just right. And once you get it started on there, you just have to slide it in and try and push it as far as it can possibly go. Now see, this is not far enough. You need, a lot of times I see students leave it kind of right on the end of it, you really need to push it as far as it can possibly go on. It probably can go a little bit further than you expected that it can, because you want to make that connection as good as possible. Once you get the first wire on, you need to go ahead and do the second wire. After you have the wires attached to the terminals, you'll route them through the hole in the robot chassis. Remember, the green wire that I have pictured here is connected to the normally open, and the blue wire I have pictured here is connected to the ground or common. Make sure your wires are still attached pretty well in the terminals, because if there's a loose connection, you won't be able to use the switch properly. Let's reference the circuit diagram shown on your screen in order to build the circuit for your switch on your breadboard. Let's start at the 5 volt and follow along as we move through the circuit. So if we're moving from the 5 volts, the 5 volts goes all the way through and then it hits the switch. It reaches the switch, and then if you continue along that switch, the switch is then connected at a node, a connection point, with a wire from pin 7 and a wire coming from the 10 kilo ohm resistor. That connection point across the 10 kilo ohm resistor is then connected to ground. Looking at the circuit diagram, that side of the switch that's connected to pin 7 and the 10 kilo ohm resistor should be my ground wire, since that is connected towards the ground across that 10 kilo ohm resistor. So I'm going to take the wire that's connected to my ground terminal. Remember, on mine that's the blue wire, that's the terminal down here on the switch, and I'm going to connect it to some row on my breadboard, because that row is going to be the node where I'm going to connect my 10 kilo ohm resistor and my wire from this pin 7. So I'm going to go ahead and connect my wire to pin 7 on the Arduino, and then I'm going to move it down and connect it to the same row as the wire coming from the common terminal on my switch. Then I'm going to get a 10 kilo ohm resistor, and I'm going to connect that 10 kilo ohm resistor from ground, as is shown in the circuit diagram, to the row or the node where all of the other wires, digital pin 7 and the common wire from my switch, are connected. Now the only thing I'm missing is connecting that wire that's my normally open to my 5 volt power supply, and I can just connect it to this line right here, and now I have my circuit built for my switch. Now you can clean things up, since these wires are going to be on your Arduino and breadboard for a long time with your switch. You might want to have the wires a little bit cleaner and a little bit more out of the way. So what I would recommend is cutting your resistor to size and cutting your wires to size. Once you have your resistors cut to size and your wires placed out of the way from the breadboard, it allows you to more easily build circuits on your breadboard for future projects while leaving the switch hooked up. Once you get your switch hooked up, you should try and write a program to test whether the switch works. Let's transition to the Arduino IDE and write a program together. In order to check if your circuit is connected properly for your switch, you should write this simple program. Start with telling your Arduino that you're going to be using your serial monitor. And so in order to tell the Arduino you're using the serial monitor, you always have to start with this command, serial.begin. Remember, don't stress out about syntax, where to put a period, where to put a capital letter. You can always look back at an old program to remind yourself where the syntax and how the syntax should fall. So it's serial.begin 9600, and 9600 is that baud rate, how fast the Arduino and the computer can communicate with one another. And you always have to do this line of code whenever you're using the serial monitor. It tells it, hey, get ready, we're going to use the serial monitor. And then we have our switch connected to pin 7. We need to tell the Arduino the mode of pin 7. So you always start with pin mode, open parentheses, and we need to tell it pin 7, and what is it going to be doing? Is it going to be an input or an output? Because remember, your digital pins are either input or output pins. When we were lighting an LED, we were sending 5 volts to that pin in order to light the LED. In this case, we're not sending voltage, we are checking to see if the switch is closed and that it can read voltage. So we're going to use that as an input. We're going to read whether or not the switch is pressed through digital input. Once you have your lines of setup, you can move to the loop. Now I like to erase these comments just so it doesn't clutter my code. You can leave them. Remember, whenever you have 2 forward slashes, that means a comment. Now in this void loop, we're going to test to see whether the switch is pressed. In order to see that, we're going to use the serial monitor to know what's going on with the Arduino. So we're going to do serial.print, and then we want to see the status of the pin. So let's type a variable. Let's create a variable that represents the pin. And so I'm going to call it switch status. Notice it's all in one word. You can put it whatever you want here. This is a variable, you're making it up. So you could put cat, you could put chicken, whatever you want for your variable, because you're going to have to define that in your program. This is something that you're making up. Notice it doesn't change color. It always stays black. So I'm going to just call it pin status, and I'm going to put my semicolon. Notice I did not put this pin status in quotation marks. That's because I don't want to print the words pin status. I want it to check to see what is the pin status. Now, as I mentioned, we just made up this term. This term is completely made up. So I need to define that because the Arduino is not going to know what pin status is. The Arduino is very intelligent, but it's only intelligent to the extent that you tell it to do things and what you tell it to do. So I need to go above my void setup loop, and I need to do a declaration of a variable. And so pin status is my variable, and so I will type pin status, and before I put the pin status, I need to tell it, well, what kind of variable is it? And by that I mean, what are the number types that I'm going to be using? And for our whisker, whether it's pressed or not is a yes or no question. The way the Arduino computes that is it reads it in terms of ones or zero. Is it pressed? No, it'll be a 0. If it is pressed, yes, it'll be a 1. So it's either a 1 or a 0. And 0, 1, 2, 3, 4, 5, 6 numbers like this are just integers. So I'm going to tell the Arduino that my variable pin status is going to be just an integer. And the way you do that is you just type int. So let me erase that and write that again so you can see it. So basically I'm going to say my variable is an int or an integer. You don't have to write integer all out because notice it leaves it black. The Arduino recognizes int as integer. And then I just type my variable that I'm going to use. A lot of times you might not know before you write your sketch what variables you're going to use. So you might just keep a track of your variables. So you might keep a track of your variables and then go back every time you introduce a new variable, go back at the top and declare them. So now I've declared my pin status. I have int pin status. And so now when it does serial.print, it knows that pin status is going to be an integer value. But how does it know what the integer value is? Well, you have to read in what that value is. So your switch is connected to pin 7. And pin 7 is what we said was going to be read as an input. And so when we were sending voltage out, when we were trying to light an LED, we used a command called digital write because we were writing to that pin to be 5 volts. Now we're not writing to the pin. We're not sending out voltage. We're reading in what that pin should be. So instead of digital write, it's going to be digital read. And so right here, before I print my pin status, because I need to read in what the status of that pin is before I can print it, I'm going to say pin status equals, and so I'm just setting this variable equal to something, and it's going to equal digital read 7. Now, when I run this sketch, it should print to my serial monitor whether or not the switch is pressed. So now I'm going to upload this sketch to my Arduino. And it was able to complete the upload. And so I need to open my serial monitor. To open the serial monitor, it's right up here. And now I have all these zeros going, so that's telling me my switch is not pressed. Now I press it and it turns to ones. So that's telling me I have my switch properly connected. There's a couple things that I don't like. I don't like how it keeps going horizontally. So let's go back to our sketch and see if we can change that. In order to get the numbers to move from one line to the next, basically we want to print to one line and then we want to move to a new line. And so in order to do that, it's very simple. You just add 2 letters after print, and those 2 letters are LN. So I like to think about it as line new. Now, when I upload my sketch, and you have to re-upload it because you changed it, open your serial monitor, and I can see my numbers are going down the serial monitor instead of across. And they're still changing whenever I press my switch. So let's recap what we did here. We told our Arduino that we were going to use the serial monitor. Anytime you use the serial monitor, you have to start with serial.begin 9600, and then we set the pin mode for any digital pins that we were using. Particularly for this sketch, we were using pin 7 as an input because we were trying to determine whether or not the switch was pressed. We weren't sending outputs of voltage, we were reading in what was going on. Then we had a variable that we named because we wanted to call on that variable later on. So I called it pin status. You could have called it switch status. As long as when you type that variable, it doesn't change colors. It's not a pre-written command or a line of code in the Arduino. So it stayed black. So that told me this was a variable that I just made up and created, and I needed to define it up here. So once I decided I was putting a variable in, I went to the top of my sketch, I declared it as an integer, and then I wrote the name of the variable with a semicolon. That should go above your setup function. We're going to talk about other variable types later on, probably in Engineering 121. In this course, we'll typically stay with just an integer. Once we declare that variable, we told the sketch what the variable should be. It was reading in whatever pin 7 was. And so we can say that here using comments, which is a good tool to use whenever you're troubleshooting your sketch, or you have someone else looking at it, or you go back to your sketch and you need to know what's going on. It's great to have comments. And to put a comment, you do 2 forward slashes, and maybe you can say setting the variable pin status to be whatever is read in by digital pin 7. And so that's really great. So now when you go back, you could say, oh, I know exactly what that line was doing. And then finally, after we got all of it set up and we read in the value, we were able to print to the serial monitor what the status of the pin was. So this line right here is printing to the serial monitor the status of pin 7. And then you might also add a little hint in there to let you know what's happening and what's going on with whatever is printed. 0 means no switch, and 1 means switch pressed. So you can reference this to let you know what you intended when you initially wrote the sketch.